Okay, so let's look at 31. These are sums for the geometric series. And notice all of these are finite series. So why don't we use the shortcut for this one? So the shortcut is for geometric finite series. We know that the sum is always going to be, let's see, what is it? It's the first term, 1 minus r to the number of terms, all over 1 minus r. Okay. If you don't use that method, then you can always do the method where you do, like in this first example, you would multiply, like if you call this s, then you could do 1.05 times s to get a whole bunch of related terms and then subtract one equation from the other. And you'll always get this thing out of it as you work it out. So let's look at A, but we'll just use the shortcut formula for these. So in A, let's see here. I've got the first term is 3,000. And this is 3,000 times 1.05 to the 0. This is times 1. This is 3,000 times 1.05 to the first. So if you think about it, I actually have 21 terms here. So n equals 21 in this case. So A1's 3,000. Yeah, that's right. R is my rate that I'm multiplying by, or my common ratio, 1.05. And n is my 21 right here. So then if I just plug into my formula, my sum should be A1, 1 minus 1.05 to the 21st, divided by 1 minus 1.05. So let me type that in and see what we get. 3,000 times 1 minus 1.05 to the, oops, careful here, I made a mistake. 21st has to go with the 1.05. And then all that divided by 1 minus 1.05. And we get 107,000, oh, I don't know why I'm putting money there. $107,157, or 7, and 7554. Okay. All right, so let's look at B. B says 18 minus 12 plus 8 minus dot 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 plus 18 times negative 2/3 to the 49th. Okay, so that means that the first term is 18. The second term is the same thing as 18 times negative 2/3 to the first. The nth general term would be 18 times negative 2/3 to the n minus 1. And if you think about it, that means that this is our 50th term. So n equals 50. And r, we can just tell from the whole thing, is negative 2/3. So I've got r, I've got a1, and I've got n. So if I rewrite this using my shortcut formula, a1 is 18, 1 minus r, which is, well, negative 2/3, so plus, to the, what is it here, 50th, all over, what is it, 1 minus 2/3, 1 minus negative 2/3. All right, so it becomes plus. So if we type that in, 18 times 1 plus 2/3 to the 50th. Actually, wait, did I mess this up? I did. Sorry, let me fix this. It's 1 minus negative 2/3 to the 50th right there. So this actually becomes positive, but that stays negative. Oh, that's kind of subtle. Okay, so let's make sure we get that right. And if I type it into the calculator, I've gotten this number, 10.799999 repeating, which is really the same thing as 10.8. Okay. Let's look at C. So C, I've got that the sum, I want the sum of 3 plus 6 plus 12 plus dot 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 plus 12,288. Okay, well, this is the same thing as 3 plus 3 times 2 plus 3 times 2 squared plus dot dot dot. And once you realize this pattern, you can start to approach the 12,288 and figure out that it's 3 times 2 to the 12th. So in this case, my A1 is 3, my R is 2, and my N is not 12, but 13, because the first term is 3 times 2 to the 0. Okay, so if I apply my formula, S equals A1, which is 3, times 1 minus R to the N, so 2 to the 13th, all divided by 1 minus R. So this comes out to be, let's see, 3, 1 minus 2 to the 13th, divided by -1. And so that comes out to be 24,573.